Please subscribe to Likhitha H YouTube channel and press the bell icon to get early notifications on my latest YouTube video updates. What's up guys, welcome back to my YouTube channel Code to Create. In today's video we're going to classify the brain tumor, if the person has brain tumor or not. And based on this X-ray images of our brain, we're going to classify this. So let's get started. We'll first import the necessary libraries. So I'm going to say from keras.applications import efficient net. I'll show you guys why you need this, not to worry. Then let's say from keras.layers import dense contouring global average pooling 2D. Then I'm going to say from keras.layers import dropout input softmax random flip. Then from tensorflow dot keras dot callbacks, yes, it's callbacks, sorry, import reduce or latitude. Then from keras dot models import sequential. From keras dot losses import binary cross entropy. Import TensorFlow SDF. From TensorFlow import keras. From TensorFlow dot keras import preprocessing. If you guys don't do this, like import TensorFlow, from TensorFlow import keras, and then from TensorFlow dot keras import preprocessing, I show you guys, there'll be an error. After this we have to import image dataset from directory for reading the image. But if you don't do it in these 4 steps, first you import TensorFlow, then keras, then from TensorFlow.keras import preprocessing, you're gonna get an error for sure. Then from TensorFlow.keras.preprocessing import image dataset from directory. From sklearn.utils import then let's import train test splits. I'm going to say from sklearn.model underscore selection then I'm gonna import train test splits. I'm going to say from sklearn.model selection import train test split, train test split. Then let's import numpy. I'm going to say import numpy as xb. Then let's import matplotlib. So I'm going to say import matplotlib dot pyplot as plb. You can also write it in a way like from matplotlib import pyplot as plt. You can write it in both ways. Let's run this now. And yes, it's done. No. Okay, till then let's just continue. Okay. sorry, this is, now let's run. From TensorFlow.keras.callbacks import. Okay, this is capital. Now let's run. Now pretty sure there won't be any errors. Let's just continue. Let's just set the number of image rows here. Let's set it to 200. And the number of columns in that image column is also 200. And the channels is 3. And then I'm gonna load the data set. So I'm gonna create a function for this. I'm gonna say def, that is for loading a function, for calling a function, or to say like not for calling a function but for creating a function. It's def load data set, and here we need the path. Run this. Data set is equal to image data set from directory. Directory is equal to path label mode is equal to categorical. Sorry, this one should, yes. Color mode, the color of that X-ray should be in RGB. Anything from this RGB. And shuffle, let's set it to false. Batch size, none. We don't need the batch size here. Image size is needed. Image size is the image rows and image columns. And then crop to aspect ratio is row. Now let's come out of this. And let's say return data set. Okay, sorry. Here. Let's run this. And then let's say dataset 1. This is for the training. So I'm going to say dataset 1 is equal to load underscore dataset. We're calling this function now. Load dataset. And here we have to give the path. So let's go there. This is for the testing. And this is for the training. Let's move to training. And let's call this here. Let's get this over here, sorry. Let's close this. Let's do the same for testing also. Dataset equals upload underscore dataset. And let's change this to testing. Then let's create a list saying images is equal to, it's just an empty list, and labels is equal to. Now let's say for image comma label in dataset 1. Image comma data in dataset 1, that is going to be the training, That's it. One images dot append image and images dot append label. And then let's come out of this from, and let's say images is equal to np dot array images. We're converting this list into an array. And then let's say labels. If you guys don't know what an array is, I've made a video about all these basics of Python. You guys can go watch it. I'll link it in the description. Let's continue. I'm gonna say labels is equal to np dot array again as array labels. And then let's say labels is equal to labels dot as type let's run this. This is first for. And we have to also repeat this. I'm so sorry guys, I forgot about that. We have to repeat this for image label and dataset. Who this is. And this is going to be labels. Let's run this now. It says error label model. Sorry, this is label mode, not model. Now let's run. Let's just continue. I'm gonna say images comma label is equal to shuffle images comma labels comma random state is equal to 10. And then we're gonna divide this, or we can say that we're gonna split this data set. So I'm gonna say xtrain comma xtest comma ytrain comma ytest is equal to train test split images comma labels and the test size is equal to 0.1. Is it completed? Yes. Let's run this now. It says the error. Sorry, this is split. And now let's plot these images up. I'm going to say plt.figure. Size of it is equal to 50. For I in range of 3, image is equal to x train of I. Let's set it to integer. We're going to plot these. That's all we're doing here. plt and dot subplot. Plus 1. plt dot show image. And then let's come out of this for loop. Let's say plt dot right layout. Let's run this. We have the images over here. We have it from the back, from the front, and from the top. Now let's create a model. Let's create our model. I'm going to say df create model. Let's say dropout rate is equal to 0.5 and flip mode is none, 0.001. Let's say model is equal to sequential model dot add input is needed for this shape is equal to, we're getting the same image rows, image columns and channels. Set it as 3, remember guys, channel. And then we're going to say if flip mode is none, then model dot add random flip. So as we have set our flip mode as none, this is gonna run. This if condition is gonna run. Then let's come out of this. Let's say model dot add. Now we're gonna use this efficient net. So this is basically used to improve the metric of any type of metric. So I'm gonna call this, if there's no other way of improving this metric, then we can use this. I'm gonna say model dot add efficient net, and then let's set the weights as image net, as it's an image classification project. And let's say include top is equal to false. Then let's say model dot add net, model dot add global average pooling 2D, and then let's say model dot add dropout, and let's say that this dropout is equal to the dropout rate Then let's say model dot add dense, and let's set the activation to softmax. Let's say model dot build, and let's compile this now. Let's say model dot compile optimizer is equal to add-on, and the loss is equal to categorical cross entropy, and matrix is equal to accuracy. Now let's say return model. Let's run this. Let's say reduce LR is equal to red. This is also for getting the metric. So this one we're gonna get it for accuracy. and let's say comma factor is equal to 0.3, patience is equal to 2, delta is equal to 0.01, more is equal to auto, one. Let's run this. This is done. Now let's say model is equal to create model, dropout rate is equal to 0.5, flip mode is equal to horizontal. And then let's say history is equal to model.fit x is equal to x train and y is equal to y train. Validation data is equal to x test comma y test, come out of the bracket, comma, the epoch is equal to 15, and the patch size is equal to 32, call backs is equal to reduce on this. After this, let's plot how our model is working. So I'm going to say it's going to take time, so let's just continue. And say plt.rc params.update font.size, that is 12. And let's create a function now for this. I'm going to say df plot performance history, epochs, and the metric. plt dot subplot 1, let's set the label now. I'm going to say set x label, this is epoch, and ax dot set y label as metric, whatever the metric is. X is equal to list, and its range between 4 plus 1, and let's say by is equal to history dot history, the value is the val plus metric. History dot history, the metric. Then I'm going to say x dot plot comma vy comma label is equal to validation x dot plot x is R label is equal to train. So let's say plt.legend, plt.grade, .canvas.raw, and after this let's say let's say plot underscore performance means history 15 accuracy, comma, accuracy, plot underscore performance history 15, and this is for the loss. Let's run this. Let's wait till it runs. So we can see it's completed. It took me about like 24 hours to get this done, like fitting this model. So it depends on your laptop and how much time it takes for fitting this model, laptop or desktop, anything. It takes like minimum, you can say, like about like 15-16 hours. It took me 24 hours. And we can see we have the plot performance also over here. It's the validation train, here again. We are seeing the epochs. So yes, we can see that we've perfectly got the brain tumor project done. Thank you guys. So yes, we can see that we've done the MRI brain tumor project properly. So yes guys, we can see that we have done the brain tumor project and it has come out like very good. So yes, thank you guys. Please do like, share, subscribe and comment below. Bye bye. So yes, we can see that we've got our brain tumor project perfect. So yes, we can see that we've got our brain tumor project done and it has come out pretty good. So yes, thank you guys. Please do like, share, subscribe and comment below. Bye bye.